To survive in higher education, your career depends on a number. Your tenure and promotion are inextricably tied to it. That number is generated by the Student Evaluation of Teaching, commonly known as the SET survey. A typical SET requires students to rate an instructor across 5 specific characteristics, usually sliding their answers across a scale of 1 to 6. To calculate the instructor's final score, universities almost universally aggregate these 5 data points using a simple, unweighted arithmetic mean. By using a simple average, the institution treats every data point as if it carries a uniform 0.2 weight. This mathematical structure dictates career outcomes, despite representing a weighting system that may not reflect how students actually perceive the classroom. This 2019 paper by Haddad, Karen, and Neve set out to interrogate that exact assumption. The structural problem with survey methodology is that if you simply ask students what is important to them, they will state that everything is important. To bypass that roadblock, the researchers designed a dual approach, first extracting theoretical weights from participants and then testing them against the behavioral reality of actual collected evaluation forms. For the theoretical phase, they utilize the Analytic Hierarchy Process, or AHP. AHP forces respondents to make difficult pairwise comparisons. You cannot prioritize everything. You must explicitly choose one trait over another. By mapping these forced choices, we can measure the exact gap between how faculty and students prioritize the classroom experience. The researchers deployed the AHP survey to 2 distinct cohorts within an engineering college, the academic faculty and the undergraduate students. This table outlines the strict Soddy scale used in the survey. It requires participants to assign a precise numerical value to their preference of one teaching criterion over another. Looking at Table 7, the first finding is a significant preference reversal between what faculty prioritize and what students actually value. Translating this data into a comparative model visualizes the disconnect. Faculty believe organization and clarity is the most significant metric, assigning it a dominant 0.35 weight. Students contrast this completely. They heavily discount organization, favoring instructor availability and a respectful, fair attitude. This creates a recurring irony in academia. Instructors spend immense time and effort optimizing for a metric that their students mathematically subordinate. To test this theoretical data against behavioral reality, the researchers analyzed 1,436 actual completed SET forms at the end of the semester. The tension here is clear. If students hold such specific, weighted preferences for fairness and availability, their evaluations should show high variance across the different questions. Instead, the data reveals a paradox: extreme range compression. In nearly 42% of evaluations, students assigned the exact same numerical score across all 5 independent criteria. As Table 8 shows, this range compression generates strong, mathematically positive correlations between completely unrelated teaching traits. Psychologists call this the halo effect. Students evaluate holistically. Satisfaction with instructor availability, their highest priority, artificially inflates their ratings of unrelated traits like organization. So, what happens to faculty scores if we abandon the equal weight model and calculate the final numbers using these empirically derived weights? This graph recreates the recalculation experiment, establishing a baseline score distribution using standard equal weights. Applying the faculty's preferred weights causes average evaluation scores to drop across the board. Conversely, applying students' preferred weights makes average scores rise significantly, particularly across middle tiers. Why do instructors score higher on traits they personally consider to be the least important? The data suggests the institution's retention processes may be selecting for instructors who naturally focus on student-valued traits, regardless of their personal teaching philosophy. The unweighted average artificially depresses teaching evaluations by ignoring the specific traits that instructors are naturally succeeding at. For higher education administrators, this data proves that using multi-question SET forms for personnel decisions generates false precision. Asking redundant questions doesn't yield deeper insight into teaching quality. It merely measures the exact same halo effect 5 times over. The institutional policy shift is straightforward. Reduce the number of criteria on the evaluation to eliminate statistical noise. For academic faculty, This data provides a framework to navigate the evaluation system for tenure and promotion. Revisiting our mathematical model reveals the optimal strategy. To navigate the evaluation, an instructor can focus effort on availability and responsiveness to students. Because of the halo effect, being highly available acts as a proxy metric for overall quality. It lifts all of your other scores and secures